David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember you can adjust the playback speed to make it faster or slower as you like. Second, you can pause the video at any point to catch up on your notes or jot down some questions. Third, you can turn on the captions so you can read my words on the screen. Today, we're going to review quadratic functions. So this is a quadratic function review. We're going to go through all the lessons we did in this chapter in our book. So to start with, we have 2 equation forms. We started out in the chapter with general form. This is y equals ax squared plus bx plus c, where a, b, and c are coefficients. Okay? And then we also developed a few lessons later vertex form, which is y equals a times x minus h squared plus k. These 2 forms tell you some things right away. In standard form, the y-intercept is going to always be 0, c. So whatever that number is, the y-intercept is 0c. So you get that right out of the form of the equation. You don't have to do any math, you can just pull it right out. Now on vertex form, you can get the vertex right out of the equation. So I usually write that as v for vertex equals. Now the trick here is you have to change the sign on whatever h is. So that's minus 3, you're going to put a positive over here. So what I'm going to do here for generally is just write hk. So these 2 numbers give you the vertex. You just have to remember whatever's on the h, you change its sign when you put down the vertex. Okay. Now, one of the first things that we did was we found y given x. So you have some quadratic function, like this one, y equals 3x squared plus 2x minus 11, and they're asking you to find out the value of y when x is 3. So this is a plug-in and simplified type of problem. We're just going to plug in our 3 wherever x is. 3 times 3 squared plus 2 times 3 minus 11. And this is going to be y equals. 3 squared is 9 times 3 is 27 plus 2 times 3, which is 6 minus 11. Crunch those in your head. 33 minus 11 is 22. We moved on to graphing quadratic equations, or graphing our parabolas. So we're going to do one of those right here. I've got this quadratic, y equals x squared plus 2x plus 1. I've made my chart here so I can figure out when my x's are these values, what my y's will be. And then I also put these in as starter values for x. I need to watch what y is so I can capture the vertex, and we'll talk about that in just a sec. So I'm going to go ahead and populate this and find out my y's. So what I did there is I just took my -2 for x, and I just plugged it in wherever x showed up in the equation, keeping my parentheses so I can keep track of what's going on. And then I can take a look at this and figure out what my y is. So, -2 squared is positive 4. This becomes -4, so now we're at 0 because I have positive 4 minus 4 plus 1, so there's my 1. Okay, so we did all our math here, and notice my y values. My first value, when I plugged in -2 for x, I got 1 for y. Then when I put in -1, I got 0. So we're decreasing, right? But now, when I put 0 in for x, I've increased back to 1. So I have caught the vertex with these 5 points. I've gone from decreasing back to increasing. So I know I've caught where the parabola changes direction. So now, let's just get a graph up here. Okay, I noticed that my largest point was 9, my largest number, so I decided to scale my axes up to 10 and do it in 5-unit increments. So let's plot some points. So now I've got my 5 points. They go boom, 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 boom. Now I just have to figure out how to draw my parabola curve, and it's actually pretty obvious here. Something like that. Okay, moving right along, one of the other things you were asked to do in this chapter was find x given y. So this is the opposite when we found y given x, which is a relatively simple one. This technique requires that we solve the quadratic equation. So for example, here's our equation, y equals x squared plus 3x minus 3, and we're being asked to find x when y is 7. So your first step with this is just to plug in. We're going to put 7 over here, because that's y, equals x squared plus 3x minus 3. Now if you remember from solving your quadratics, you need to get 0 on one side of the equation. So to do that, we're going to subtract 7 from both sides. Now I'm subtracting 7, so subtract 7 from negative 3 is going to give me negative 10. Now in this case, we're going to take a look at this quadratic and see if we can factor it. And in fact, it's very factorable. If you want to try that, pause the video right now and see what you get. Okay, check it out. It's a product sum type factoring. At least that's the first thing we're going to look for. What two numbers multiply to negative 10 that add up to positive 3? And those are positive 5 and negative 2. So what we get is x equals, or 0 equals x plus 5 times x minus 2. Now if I FOIL this, I'm going to wind up back here. If you're not sure about that, you can check. Okay, so now I have two little mini equations to solve. I have x plus 5 equals 0. That gives me x equals negative 5. And in this case, I have x minus 2 equals 0. And that gives me x equals 2. So we can write the solutions to this equation in set notation with minus 5, 2. Okay, let's take another look at vertex form, and let's use it to make some graphs, which is really what it's for. Okay, so I want to talk about a key word here first, using vertex form to sketch quadratics. So sketch isn't just a casual term, it means sketch the quadratic without plotting points. So that last section where we graphed it, we figured out what all the points are and we plotted them and we graphed, the vertex form technique doesn't involve that. It involves plotting some key points and then using what vertex form tells you about the quadratic to create a reasonably good quadratic graph. So let's do some. Okay, here's our first one. Y equals x minus 1 squared minus 3. So let's first figure out what the vertex is. The vertex is change the sign on the x and bring that over. So my vertex is the point negative 1, 3. Okay, so I'm sorry. My vertex is 1, negative 3. So 1, negative 3. It's right there. Now check it out. There's no a out in front here, but there is a positive 1. So it's positive, which means the parabola opens upward. Also, there's no a here, so the shape is the same as y equals x squared. So from that graph, which you need to understand, you know that your first 2 points are up 1 over 1. So that's 3 points. That's enough to sketch our parabola. Something like that. So if you think you have this technique, then give this one a try. Okay, first step, find the vertex. The vertex is change the sign, minus 2, keep that sign. So the vertex is at minus 2, 2. Let's get some tick marks on our axis. By the way, I am fine as your teacher. If you don't put any numbers on your tick marks, I'm going to assume that they each equal 1. Okay? So if you want them to equal a different number, you've got to tell me what that is by putting the numbers on there. Okay, so minus 2, 2 is minus 2, is 2 over to the left, and then up 2. So there's our vertex. Now let's take a look at our A. Notice how there's no 1 there, but we could write that. So this is minus 1 over on this part. So that tells us, because it's negative, that the parabola is going to open downward. This is going to be a high point or a maximum on the parabola. Also, since a is negative 1, the shape is going to be the same as y equals x squared, like we talked about with this one. So now we can get these 2 more points that we did on this graph, but we're going to go down. So it's over 1, down 1, over 1, down 1. So there's that parabola. One last one. Pause the video, give that a try. Okay, let's do the vertex. Vertex is negative 1, 1. Change the sign here, keep the sign there. Let's graph the vertex. So negative 1, 1. There's our vertex. Now, suddenly we have an A. All right, so this is going to change the shape of our parabola. A is positive, so the parabola's going to open up, and our A is bigger than 1, so it's going to make a narrower parabola. One way to think about this is you do all this math to get your x value, you're going to double it with this 2. So instead of over 1, up 1, you're going to go over 1, up 2. Over 1, up 2. So that creates a slightly narrower graph than these two. Because vertex form is so valuable, we use a technique to convert a standard form quadratic equation to vertex form. So that's what we're doing. It's called completing the square. And here's how we do that. Here's our standard form quadratic. So the first thing we need to do is first make sure y is alone on one side, and then we have standard form. We need to figure out what this is. B over 2 squared. Now b is that number there on the x term. So this is going to be 6 over 2 squared. 6 over 2 is 3, squared is 9. So our b over 2 squared is 9. Now what we do is we take it and we add it and subtract it from the equation. So this becomes y equals x squared plus 6x plus 9 minus 9 plus 12. So here's the cool thing, is that we haven't changed this equation a bit. We added 9, but we subtracted it right away. So we didn't break the equation. But here's what's cool about that, is by doing this, that became a perfect square. So this always factors down into x plus or minus, in this case it's plus, half of the b. Combine these two, have my y equals. Now I'm in vertex form. Okay, so 4 steps. You want to state your vertex once you get there. Change the sign, like so. All right, let's move on to looking at intercepts. The intercept of any graph is where it crosses one of the axes, like the x-axis or the y-axis. Parabolas can have up to 3 different intercepts. Okay, so check this out. Here's a parabola I've sketched on my x and my y coordinate. The x-intercepts are where it crosses the x-axis, and at that point, x equals 0. Okay, and we're going to exploit that in a minute. The y-intercept happens where the graph crosses the y-axis, and at that point, x equals 0. Okay, so those are the things to remember about that. And then also, we talked a little bit about how every parabola crosses the y-axis one time. Okay, it has to do that. But the x-intercepts can have 0, 1, or 2. Okay, so you could have none. Think about this. Here's a parabola that opens upward that's above the x-axis. There ain't no x-intercepts. Same thing with pointing down below, no intercepts. Finally, you could have 1 intercept if the parabola comes down and just kisses the x-axis at 1 point. So that's how you would get, here's 2 intercepts. These two have no intercepts, and that one has just 1 intercept. So be on the lookout for those kinds of parabolas. Okay, so once you understand what intercepts are, then we moved on to finding them. So finding the y-intercept is pretty simple. We talked about that at the beginning of the video here. It's always going to be 0c. Whatever that term is, it's going to be 0 that term. So for example, here's a quadratic equation, 3x squared minus 9x plus 13. Pause the video and see if you can figure out what the y-intercept is. Okay, let's see how you did. That's just going to be 0, 13. Okay, because that 13 is hanging out there. And check it out. At the y-intercept, x is equal to 0. So if we plug that in here, these two terms, if you plug 0 in, they go to 0. All that's left is the 13. So that's why we've got that point. Now the x-intercepts are a little bit more complex to find. So what we do is we factor and solve the quadratic. Okay. So to do that, I need to find out how this works. So check it out. For factoring, this is going to be another product sum factoring. I need 2 numbers that multiply to -8 that add up to positive 2. And that would be positive 4 times -2. So I can do x plus 4 times x minus 2. That's a factorization of that quadratic. Now to solve, I set y equal to 0. And again, on the x-axis, y is 0. So that's why we're doing this. This is going to give us two little equations. X plus 4 equals 0. That gives us x equals negative 4. And this one is going to be x minus 2 equals 0, which gives us x equals 2. Now the answers at the back of the chapter for our textbook show these as the solutions. They're just saying negative 4 and 2. Personally, I think it's much better to do it like this. Minus 4, 0, and 2, 0. Because the intercepts are coordinate points. So they have an x and a y value. So if you're being asked for the intercept, it's best to show it as a point. We also did a lesson where we made sketches of quadratic graphs using the intercepts only. Okay? And remember, it's a sketch, so it's not as accurate as if you plotted points. But in this case, you don't have the equation. You just have the x-intercepts and the y-intercept, and we're going to go ahead and just solve this or graph this quadratic. So my biggest point is 4, so I'm going to go ahead and just do it like that. And we're going to put in 1, 0, there's that point. We're going to put in 4, 0, there's that point. And then, so those are the x-intercepts, and then the y-intercept is 0, 1. So now we need to draw a quadratic that goes through all three of these points, and it's going to be something like this. Okay? Now, there's no way you could draw a curve, a smooth quadratic curve, through those 3 points and have it open down. So that's the key. It's hard to see sometimes from the points you have exactly how you could draw your line. Now that you've watched the video, take a moment to jot down any additional notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.